Hi, I'm just making a quick video to wrap up graphing tangent and cotangent functions. So we went over some of this, but I just want to kind of review a little bit and then be able to work through the last couple of examples in the notes. So the first thing I have listed here is just an an, uh, a two, an XY T chart for various x values in tangent and cotangent. So you can see, like, if we take tangent of 0, we get 0, right? Tangent of pi over 6, we get, square root of 3 over 3. And then obviously cotangent is a reciprocal of tangent, right? So, where tangent's 0, cotangent is undefined. Where tangent's undefined, cotangent's 0, and so forth, right? So we can get this information from points on the unit circle, right? We just take sine divided by cosine, and you can come up with these values, and then cotangent is just the reciprocal, right? So just to make that clear, right? Recall that tangent of theta equals sine theta over cosine theta, and then cotangent of theta is just equal to 1 divided by tangent theta. Right, so the reciprocal of tangent, right? So that's how I was able to come up with these outputs, these y values, right? So you could practice that and double check me here, but that's where I got it. And I went from 0 to pi, right? Because remember, the period for tangent and cotangent, the period is pi, right? Where the other trig functions, the period is 2 pi. So cotangent and tangent work a little differently. So if we go to graph these points, where you're going to get a shape looking something like this, right? So this is the graph of tangent, and we can get more points, right, to be able to fill this in good. But one thing you'll notice is that in between negative pi over 2 and pi over 2, we kind of get one period of tangent, right? So one period of tangent is in between these vertical asymptotes at negative pi over 2 and pi over 2. So every pi over 2, or excuse me, it would be every odd multiple of pi over 2. That's where we're getting these vertical asymptotes, right? So remember, we looked at that last time, and that's where we defined where tangent is undefined, right? So then here is a table, and it's just wanting us to pay particular attention to. So this wording here, saying as x approaches pi over 2 from the left, right, that negative sign here means from the left that tangent of x, the output of tangent of x, approaches infinity. And then as we approach pi over 2 from the right, that plus sign means from the right, tangent of x approaches negative infinity. So if we go back to looking at the graph, right? So here's pi over 2. So if we're approaching it from the left, right? So we're looking at x values as we increase to the left. Notice these y values just keep getting bigger and bigger and bigger, right? So the graph is going upward, right? So that's what that's describing, right? So you may have if you take calculus, you'll see that notation a little differently, using limit notation, but that's just getting you to think about as x goes towards pi over 2 from the left hand side, my graph is increasing, right, indefinitely, right? That's what this first box is describing. And then the second one is if we're approaching it from the right, right? So if I'm coming at the graph from the right side towards pi over 2 still, what's happening to the graph. So we're looking down here, right? So these values, as x gets closer and closer to pi over 2 from the right, notice my y values are decreasing. They're actually going downward, right? So that's why we say it's going towards negative infinity, right? They're going downward forever, right? So that's what that box is referring to, right? So just something interesting to note is how on either side of these asymptotes, they're kind of going in like opposite directions, right? They're like they're trying to hug the line, if you will, right? But they won't cross the line, right? Because tangent is undefined at the odd multiples of pi over 2. Right, so then here's a graph of cotangent. So remember, cotangent is undefined at multiples of pi, right? So notice you'll see the vertical asymptotes at pi. And actually this y-axis here is also a vertical asymptote, right? So maybe kind of hard to see because it's a dashed line and a solid line, but this is a vertical asymptote here as well, right? The y-axis. Right, and notice it looks similar to the graph of tangent. So some things that are different is it looks like it's shifted to the right, pi over 2 units, and then also reflected about the x-axis, right? So if you can imagine taking this dashed line and bringing it over here, that would give me, that would just put this where, let me do some erasing here. If we did a phase shift, so if I brought this over here to line up with the y-axis, x equals 0, then this part of the graph would move over, and this, so my asymptotes would be here, right, on the y-axis, and then at pi, and then my graph would look something roughly like this, right? So it's going, it's like increasing, right, as we go through the graph. But if we look here, that this as x gets bigger, my graph's kind of like decreasing, right, for cotangent. So it's kind of like a flip then across the x-axis, right, a reflection across the x-axis. So shifting in a reflection across the x-axis is what kind of the difference between the two, right? Remember, sine and cosine, the only difference is it's just shifted a little bit, right? Pi, it would be what? Pi over 2 units, right? So then what I have listed here are graphs of tangent and cotangent, and this is just a table kind of putting everything together. So we already knew the domain. We looked at that in the last section. But something new here that we didn't know is the range. So like by looking at these graphs, right, we can tell the range, the possible y values are going to be all real numbers, right? So that's going to go, negative infinity to infinity. And then the amplitude here is none, right, since the range includes all real numbers, so there's no amplitude. And then we already knew the period was pi for both tangent and cotangent. And then we knew where tangent and cotangent were undefined, right, by looking at the domain. So, the kind of the new thing here is that's where these vertical asymptotes are going to show up in the graphs, right? And then we also already knew the symmetry, right? So then what I meant to have you write here, and I was able to write it on the board really quick before we ran out of time, is the following. I wanted to write y equals a times tangent of b to the x minus c plus d, and then y equals a times cotangent of bx minus c plus d. Right, so these are just those generic forms that we've been looking at all along. And here, remember, we're assuming that b is bigger than 0, right? And if b is negative, we looked at how we can factor out that the negative from the bx minus c, and then rewrite it using even and odd functions. Right. So, just some notes is that the absolute value of a is going to equal the scaling factor. Right, so we don't have an amplitude here, but this is going to cause the graph to stretch vertically, stretch or shrink vertically, right? So we have this vertical scaling factor, right? So let me just make a note. This is vertical, right? So that's going to be a stretch or a shrink vertically. And then, if a is negative, if a is less than 0, that's going to reflect the graph about the x-axis, right? So the graph is reflected about the x-axis, right? And then to tell the period, so remember the period for a sine and sine and cosine and secant and cosecant are 2 pi, so we would take 2 pi divided by b. But in our case of tangent and cotangent, the general period is actually pi, right? So the period for these, tangent and cotangent, we're going to find that by taking pi divided by b. Right, so then next thing we want to look at is the phase shift. Right, so remember that's just a fancy way, for horizontal shift, right? We use the term phase shift when we're using trigonometric functions. So the phase shift, you're going to calculate that by taking c divided by b, right? So that stays the same. And then the vertical shift also stays the same. That's just equal to capital D, right? Equal to D, right? So little variations, but not much, right? Same general principle for finding these characteristics of the trig functions. So the next part of the notes, I just took this table from the textbook, just giving some guidelines for graphing tangent and cotangent. So the first thing that we're going to do is try to identify where the vertical asymptotes are going to be, right? So if it's just tangent of x, the vertical asymptotes are going to be, at odd multiples of pi over 2, but kind of like the first period is in between negative pi over 2 and pi over 2. Right, so what we're going to do is take these values and throw it inside of here, and then solve for x, right? Because that's going to, that's going to take into account the horizontal shifting and stretching and shrinking, possibly shrinking going on, right? So that's going to take care of that for us, so that way we know between what two intervals like that general period is going to be in between, and that's going to give us a clue to where the vertical asymptotes are going to be, right? So this first part is all we're trying to do is find the vertical asymptotes, right? And then for cotangent, that first kind of general period is in between 0 and pi. So same idea. We're going to throw in, the whatever's inside, the trigonometric function, and put that in between 0 and pi, and then solve for x, right? And then the next part we're going to do is plot an x-intercept. So that's always going to occur halfway between those asymptotes. So we can, cut that distance between the asymptotes in half, plot a point, and then, maybe get 2 other points, maybe in between the vertical asymptotes and the x-intercepts, halfway in between. That will give us a couple other points, so that way we get kind of the shape down, and then we can sketch additional cycles if we would like. Right. So let's try try these examples now. Give us some practice. Right. So I have graph y equals 4 tangent of pi over 2 x. Right, so remember the first thing that you kind of want to do is let's identify where those vertical asymptotes are going to take place. So I'm going to take this part, right, the part that's that's inside the trig function. I'm going to take that and then place it in between negative pi over 2 and pi over 2 for tangent, right? So then I want to solve for x. So in other words, what I can do is multiply by 2 over pi, which is essentially the same thing as dividing everything by pi over 2, right? So we're trying to get rid of that coefficient for x. So I'm going to multiply everything times 2 over pi. I have to do both sides of this compound inequality. So on the left, that's going to give me negative 1 less than x less than 1. Right? So x is going to be in between negative 1 and 1 for that vertical asymptotes, right? So I know I'm going to have vertical asymptotes at x equals negative 1 and 1. Right? So I could come over here, since I have graph paper, and we can add what we have to this. Right? So let this be 1, 2, 3, 4, and so forth. I'm going to want this to come up a little more. Right? So what I've found right now is I'm going to have vertical asymptotes here. Right? And then if I figure out the period, I could figure out where those are, right? So the period, right, remember, is pi divided by b. My b value in this function is pi over 2. So if we take pi divided by pi over 2, we get pi times 2 over pi, which is 2, right? So my period is 2, which makes sense because I have 2 units, right, in between these red tick marks already. So I'm going to have another set of asymptotes, a distance of 2 to the right. And then also 2 to the left. Right. Sorry, it's hard to get this get those straight. Right. So then remember, the next step is plotting. We're going to have x-intercepts right in between negative 1 and 1, so that would be at 0. And then we want to think about finding the y-coordinates for right in between the vertical asymptote and the x-intercept, and then in between the x-intercept and the vertical asymptote. So in other words, I want to find, if I plug in x equals negative a half and positive a half, what's the y-coordinate? Right? So, for negative a half, we would have y equals 4 times tangent of pi over 2 times negative 1/2. Right? Which equals 4 times tangent of negative pi over 4. Which is, so all students take calculus. Right, so negative negative pi over 4 is going to be down here. So my tangent value is going to be negative. And tangent of pi over 4 is 1, right? So this would equal 4 times negative 1, which is negative 4. Right, so maybe making this a little condensed. If I plug negative 1/2 in, we should get negative 4 as the output, right? So then now for a positive 1/2, right, we would have y equals 4 times tangent of pi over 2 times positive 1/2. This gives me 4 times tangent of pi over 4. Well, pi over 4, tangent is going to be positive, and it's going to be equal to 1, right? This would be 4 times 1. Oops. Which is, of course, just 4, right? So now if I plot these points, this is just going to kind of help me gauge. So negative 1/2, negative 4 would be here. Let me go grab a different color. I'll do green. Right, so negative 1/2, 4 would be here, right? And I know that I already have this point. I have a point here. And then 1/2, we have positive 4. So then my graph, my function, is going to try to, kind of hug this line, so we get something like this. Right. So then, if I want to graph more, additional periods of this, right? Or I guess call them cycles, right? If I want to graph more cycles, then here, I'm going to have an x-intercept here, and then halfway in between, we're going to be at negative 4, and then halfway in between 2 and 3, at 2.5, we're going to have positive 4. So then my graph, it's going to look like this. Right? So then here, I'm going to have x-intercept here, and then we can plot the point halfway in between at negative 4 and over here at 4. So they're remember, they're exact copies of the previous, of the cycle that we drew. Right? So that's what we do. So just to recap, right, we're going to focus on the vertical asymptotes, graphing one cycle, and then you can graph the other cycles just as copies of that. Right. So then for example 4, we're graphing cotangent, but also you'll notice that we have a vertical shift of down 3 units. So similarly to when we looked at doing secant or cosecant, we kind of ignored the shift at first and then applied the shift after we had a graph established. And you're going to want to do the same thing. I would do the same thing here. Right. So first of all, cotangent is going to be in between 0 and pi. So we would have x plus pi over 2 in the center, right? Because that's what's inside the trig function. And then I want to solve for x, so I just need to subtract pi over 2 from both sides. So that's going to give me negative pi over 2 less than x less than, that would be pi over 2, right? So those were my horizontal, my vertical asymptotes are going to lie, right? So if I come over here, right, so we have pi over 2, pi, 3 pi over 2, 2 pi. All right, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. Right, we can graph more if we need to. But what I know right now is my vertical asymptotes are going to be here at negative pi over 2, and at pi over 2. Right? So in the period, it would make sense for it to be pi, right? So we can double check that. And it's easy to see because my b value is 1, right? The coefficient for x is 1. So my period would be equal to pi divided by 1, which is, of course, pi, right? And we can, make sense of that because there's pi units in between the vertical asymptotes. So we're going to have more vertical asymptotes at 3 pi over 2 and negative 3 pi over 2. Right? So then I know I'm going to have an x-intercept right in between, right? As we did before. And then we just need to find a value right in between. So let's do negative pi over 4 and pi over 4. Oops. Sorry, I meant to write that there. All right, so these are my x values. And just to keep in mind, right now what I'm thinking about doing is graphing this function, cotangent of x plus pi over 2, right? Because we're ignoring that vertical shift for now. So if I plug in negative pi over 4, we would have y equals cotangent of negative pi over 4 plus pi over 2, which this would equal cotangent of, so we want to get common denominator, so that would be negative pi over 4 plus 2 pi over 4. All right, so just to get common denominator, which that gives me cotangent of pi over 4. Right? So cotangent of pi over 4 would be 1, right? Because if you need to think about that quickly, right, remember our special right triangles, like if here's pi over 4 and here's pi over 4, this would be 2, radical 2 and radical 2. So we're thinking about it maybe from this angle, right? This angle here, right? Labeled that theta. Cotangent is the adjacent over the opposite, right? So you'd have radical 2 over 2. But recall, earlier we did tangent of pi over 4, but that would be the opposite, which would be this pi over 2 over adjacent, which is pi over 2, which also gives you 1, right? So tangent and cotangent are both equal to 1 at pi over 4, right? And we're in the first quadrant, so it's going to be a positive 1. All right, so this equals 1. And then if I plug in pi over 4, I'd have y equals cotangent of pi over 4 plus pi over 2, which is cotangent of pi over 4 plus 2 pi over 4, which equals cotangent of 3 pi over 4. Right? So 3 pi over 4, if we want to draw that, right, where this part is pi over 4, right, that's my reference angle, and here's, here's like theta, if you will. So we're in the second quadrant, so this is going to be negative, right? Because remember, all students take calculus, so tangent and cotangent are negative in the second quadrant. So my reference angle is pi over 4. So I already know cotangent of pi over 4 is 1. So this is going to be negative 1, right? So if we plot these points, so this would be at 1, and this will be at negative 1, right? Halfway in between, where I'll let these tick marks just increase by 1. Right? So then now we know the general shape of the graph, right? It's gonna, open this, since this point's above the x-axis, that tells me it's gonna open above, and then this is gonna curve down, right? So we just kind of draw that S looking shape, right? It kind of looks like, maybe the graph of x cubed, right? Kind of in a sense. Right, so then we can graph the other copies, right? The other the other cycles, right? So like here, we're gonna have an x-intercept here, and I'm gonna have one here, and then I'm gonna have a point at positive 1 to the left and negative 1 to the right. Same thing here. So then it's gonna like hug the asymptote and make like this S shape. Right, so we get something like this. Right. So remember, though, we're not done. This is without the vertical shift in it. Right. So what's going to happen is we're just going to drop down 3 units. Right. So oops. Well, I thought maybe I could just drop that down. Let me just I'll use a different color, go in black, right? Whoops. Didn't mean to do that. Right, so what that's going to do is just drop everything down 3 units, right? The minus 3. Right, so if I apply this, this point's going to drop down 3 units, so it's going to come down here. This point's going to drop down 3, 1, 2, 3, so that'll be here. And then this point drops down 3, so it'll be here. The vertical asymptotes won't change, right? So if we just plot these in my 3 periods, then we can quickly get the correct graph. The graph that we're trying to the graph that we were asked to graph. Right, so that's the correct graph. Right, so just to be clear, in the black, that's y equals cotangent of x plus pi over 2 minus 3. And then in the blue, that was y equals cotangent of x plus pi over 2. So we weren't doing the vertical shift. Right, so now we have all of those graphs graphed correctly, and it's kind of hard for me to graph these really well on the computer. I have a hard enough time by hand, but if you want to see like a good a better version of the graph, you can use like your graphing calculator or Desmos, as we did in class. But keep in mind, those graphing tools, aren't going to show the vertical asymptotes, but you can get a better picture for like how that S shape looks and things, right? And you can look at a table and find the points and so forth, right? But that's all I have. So let me know if you have any questions, and good luck studying for the midterm exam. Thanks.